section 3.5. This is the last section in chapter 3. What I want to start off with you guys doing is actually looking at page 257. 257 will give you all 5 of these models. They will give you examples of their equations and also show you the graphs. And you will want to at least be able to kind of see what they look like. The biggest thing though, this exponential growth equation is one that you will need to know just kind of overall as we're going through. The rest of them, if you need a formula, we'll give it to you. Okay? So let me slide this down. I'm going to start with the actual examples. The first one says Mr. Wilcox has $62,000. He wants to know what interest rate compounded continuously, that's huge for us, is needed so that he has $150,000 in 18 years when he retires. Now, since we're talking about compound continuously, then our model that we're going to use is just the general equation, A equals PE to the RT. We're talking perps. This is also a basic idea of exponential growth. Again, we're growing money so that you can kind of look there. For the equation, I'm going to put all of the equation in the work over here. So as I look at this, let's start. $150,000 is what he wants. $62,000 is what he started with. Since we compound continuously, we have a base E. And it's 18 years, and we're trying to find the rate, so we call that R. Let's go through and solve like we did then last section. When you divide by 62,000, you end up getting about, and I'm going to round 3 decimal places today, about 2.419 equals E to the 18R. And this basically now sets us into yesterday. Okay, if I have a base E and I'm trying to get rid of the base to get to the exponent, because it's base E, I'm going to natural log both sides so that the natural log and the E would cancel. And the natural log of 2.419 is approximately 0.883, and that's now going to equal 18R. So if I divide both sides then by 18, our R says 0.049. Okay, and I'm liking 3 decimal places. It gives us a more exact answer. Now the question they're asking is, what is the interest rate? And we don't normally say 0.049. In a normal story problem, they tell you this is about 4.9%. And I'm going to put approximately because we rounded some decimals along the way. But basically, if he's compounding this, he needs to find a bank that could give him about 4.9% in order to make the $150,000 for the 18 years. Okay. This is a definite type quiz question where we ask you something like this. Absolutely could see this. A second one though here, this second one is a definite. I can tell you it's going to be on the quiz. It's going to look a little different in their story that goes along with it, but it's going to have the same idea. There is a video up on the website if you need help with this question. It will walk you through this. So here's what it says. Fish is a band that Mr. Wilcox loved. They started in 1983. In 85, which they called time 2, there were 1,200 fans. But by 87, which if I start at 83, that's time of 4, they had 3,600 fans. This is a big assumption, but assuming exponential growth, and exponential growth from above is y equals a times e to the bx. And this is why you need that equation. I told you that was the one equation you need. Assuming exponential growth, the question is how many fans will they have in 2000? And I'm going to put a time on that a second because this is pretty important. This is a time of, if I started in 83, a time of 17. Okay, so here's what they actually give you. They give you 2 points. The fact that at time 2 I have 1,200, and at time 4 I have 3,600. And this is like our x and our y, then we're going to plug in our equation. So you're going to start with 2 equations. The first equation's going to say 1,200 equals, I don't know my starting amount, so I'm going to leave that as E, and I don't know my value of B, but I know that x is 2, so I'm going to say to the 2x. I'm sorry, to the 2b. Let's keep my letters correct. To the 2b. And then I'm going to write a second equation for that other one. So I'm going to say 3,600, and again, I don't know my starting amount, equals a times e to the 4b. Okay, now that I have two equations, we're going to use substitution. So what I'm going to do is solve this first equation for a. So if I divide by e to the 2b, these go away, and basically a is 1,200 divided by e to the 2b. And what I'm going to do is I'm going to stick that in the second equation where my a is. So I'm using substitution. So 3,600 equals, well, I had 1,200 over e to the 2b is what a is, times e to the 4b. And this is like an over 1. And according to our exponent rules, we can subtract those exponents. So you get 3,600 equals 1,200 e to the 2b. And now I'm going through and solving. So if I divide by 1,200, 3 equals e to the 2b. And because it's a base e, I'm going to natural log both sides. Once I natural log, this cancels out. The natural log of 3 is about 1.099 equals 2b. So when I divide by 2, b is approximately, and I'm going to go out a little farther just based on what the decimal says, 0.5495, just because I didn't want to have to round a little closer. So we have our value of b. Okay, and the goal is to get a general equation so that we can actually end up figuring out how many fans were there in the 17th year or year 2000. What I'm going to do now, so I first took this a value and I plugged it in. Now I'm going to take this b value and plug it back into my a, because my goal is to figure out what a is also. So 1,200 divided by e to the 2 times 0.5495. This ends up getting that a is about, let me find my value a second, 399.84. Okay, so what I'm going to do is take this a and this b value and I'm going to plug it in to write my general equation. And my general equation will then say 399.84 e, and then b is to the 0.5495t. And this is the equation then we're going to use to actually answer our question. So if our question was, well, how many fans in year 17, let's get rid of this, then what we're going to do is plug a 17 in for t. So 399.84 times e to the 0.5495 times 17. And make sure when you put it in your calculator, all of that is in parentheses. You should end up getting that there are about 4,558,775 fans. Please do not write a decimal. We don't count partial people. But this is the idea. And again, if you're not sure on this, maybe you erase what you have or grab a separate paper and try it again. Or again, there's an extra video on my website that does this same question with different points, but it again picks 2 points and say, can you write an equation? Okay, go ahead and flip the page. This next one, carbon dating, this will also be on either the quiz or the test. I don't remember which one, but I can tell you it will be assessed. We will give you the equation. Okay, we will give you the equation. So here's what's going on in this one. Carbon dating basically is the same thing as a half-life, and they kind of figure this out to determine basically how old a fossil is. And so what we're going to do is, can we find a fossil which has a ratio of 1 over 10 to the 14th? So we're going to set this up. 1 over 10 to the 14th equals 1 over 10 to the 12th e to to the negative t over 8223. Okay, now my goal is to get rid of this fraction first. Instead of dividing by a fraction, we multiply by its reciprocal. And we use our exponent rules here to get 1 over 10 to the second. This is 1 over 10 to the second. I'm going to switch this to say 1 over 100 equals e to the negative t over 8223. Again, we have a base e, so we're going to natural log both sides. Put parentheses around this in your calculator when you do that. You end up getting negative 4.605 about is negative t divided by 8,223. And my goal is to get rid of the negative and the 8,223 at the same time. So I'm going to multiply by negative 8,223 on both sides so that the negative and that cancel out. And you end up getting, again, time is how many, let's look back at our equation, how many years? Okay, so when I look at this, you don't necessarily need a decimal. I'm going to go approximately 37,867. Just don't forget the label, though, years. So here's our answer. Okay. The question, we didn't fill out the model to start, but let's take a look. It's a times e to a negative exponent. That means it's exponential decay. And so it's y equals ae to the negative bx. And so that's the idea of exponential equation. Too small to write in there, but that's that first step where we figured out what set it equal to 1 over 10 to the 14th. Okay. This next example, this one right here, is actually the same example as in your book. So I want you to look directly at your book for this example. Basically what they're wanting you to see is how does the average, if you make a bell curve for the SAT scores, their question is basically where in the equation do you find the mean or the average score? And so I want you to take a look at that right in your textbook. All right, we've got two more. And in 1991, East Kentwood had a high school of 1,800 students. One student returned from spring break with a contagious and long-lasting flu virus. This spread of the virus is modeled by this equation. And I actually need to change a few things. I'm sorry, I took this equation directly from your book. Instead of the 5,000, let me write your equation down here. It should be 1,800 because we started with 1,800 students. In the denominator, it should say 1 plus 1799. It's 1 less e to the negative 0.8t. And so I just want to change that. I apologize. Where t is the number of days, if 30% of the student body is infected, school gets canceled. Okay, so the question is basically how many days until how many were infected on day 3, and then how many days until school is canceled. Okay, so let's start with the first question. Actually, this is called a logistic model, and you could see this fits the form on the front page for a logistic. What we're going to do is start from the first one. What happens in the third day? And so I want you to stick this in your calculator and figure out how many students were affected on the third day. So negative 0.8 times 3, that needs an extra parentheses. You'll probably need a parentheses around the denominator, but you should end up, make sure you can get this in your calculator, you should end up getting about 11 students. Again, do not give people in decimals. That's kind of the #1 mistake we make. The second thing that we asked is how many days until school is canceled? Okay, so as we look at this, here's the big thing. We know that 30% of the student body has to be infected in order for school to be canceled. So what you'll need to do to start is take our 1,800 students and multiply it by 30% so that we know what we're supposed to get it to equal. So it's supposed to equal 540, and let me draw a line here a second so we've got some place to work. So 540 students would mean that our school gets canceled. So 1 plus 1799 e to the negative 0.8t. And in order to solve this, what we're going to do is multiply by the denominator, and to save myself a little space, we're going to multiply the denominator so the denominator cancels out. So here's what I have. I have 1,800 then equals 540 times 1 plus 1799 e to the negative 0.8t. Okay? And do not distribute the 540. We're going to get rid of that first. And once I think you see this set up, then it's not too bad. Okay, so this ends up being 18. This is, I left mine in fraction form, so I apologize. This is 10/3. Because you end up getting a crazy decimal, equals 1 plus 1799 e to the negative 0.8t. I'm going to get rid of the 1 first. And let's do a fraction a second. I'm going to run out of room here. All right, 10/3 minus 3/3 is 7/3. We're then going to divide by 1799. You end up getting then that e to the negative 0.8t equals, in a decimal, about 0.0013. Because again we have a base e, and this kind of seems to be the trend in the story problems, we're going to take the natural log of both sides. So that negative 0.8t equals the natural log of 0.0013. And to try and save all the decimal work, I'm just going to show it to you this way. What ends up happening then is t is about 8.41. And so if we talk about this in terms of days, how many days until school is canceled, boy, you could say about 8.4 days, as long as you keep that in. 8.4 days, 8.5 days. Maybe you say you can't go until a full 9 days because too many people will be infected. So maybe you say we have to dismiss at 11, something like that. Don't actually say that, but this is the idea as you're going through to solve. And I wanted you to see solving a logistic, so you saw that to multiply by the denominator first will end up making things a lot nicer. Okay, the last one talks about the magnitude of an earthquake. This is a logarithmic model. Okay, and I think you can kind of see some of this from what's happening from the first page, but take a look. They want to know, given this equation right here, I with a superscript of 0, the initial is always going to be 1. So take a look. They want to know, when is the magnitude 9.2? So let's set this equal. The first one, let's do part A. 9.2 equals the log of, basically, I divided by 1, so I'm just going to say the log of I. Now, if you look at this, this is a base 10. And so talking about what we did yesterday, you could rewrite this, or because it's a base 10, I'm going to take 10 to this side and 10 to this side, because then 10 and the log base 10 will just eliminate each other. So basically, I is 10 to the 9.2 power, which is about, here we go, 1,1,893,192, and I want to have some sort of description, and it doesn't look like I give it to you in the story problem, but I believe it's wave energy based off the question like this. There's a question like this in your book. B basically does the same thing. I mean, it says, now this time take 4.60 equals the log of I. If I take 10 to this side and 10 to this side, then 10 to the 4.6 is what I is, which is about 39,811 wave energy. Okay, so I wanted you to see this example again. It's just working with logs one more time. But again, I'm going to cross this off because I tend to modify my homework assignments based off others as well. But this is the idea when you're solving log equations. These are story problems behind it. You will see story problems on both quizzes and tests. So thank you for watching. That's the end of chapter 3.